everyone, this video would focus on concurrency of medians of a triangle. Before we go over this figure that we have right here, let's define concurrency and median of a triangle. We remember that if we say point of concurrency, it is referred to as the point of intersection of lines, rays, or line segment. So in this case right here, we call this as the point of concurrency because these line segments are touching each other at this point. Now, there is a special name for this point of concurrency. We call this as the centroid. On the other hand, if we say median, median is a line segment joining a vertex to the midpoint of the opposite side. So in this figure that we have here, this is one of the medians. So it starts from the vertex, it goes all the way to the midpoint of the other side of the triangle across from that angle. So this point G, point E, and point F are the midpoint of each of these sides here. So again, this DG, AF, and BE are median. It goes from the vertex all the way to the midpoint of the other side across. This tells us that this line segments AG, GB, DF, FB, and ED and AE are congruent since points E, F, and G are midpoints. In this part, we will be focusing on the length of the line segments, which is the median. We remember that the median of a triangle intersects at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Meaning if we look at this median DG, the length of DC is actually 2/3 of the whole thing. The length of BC is actually 2/3 of the whole thing. And the length of AC is actually 2/3 of the whole thing, provided that these are medians of the triangle. So I'm just going to go ahead and write that statement up here. This formula tells us that the length of DC is actually 2/3 of the whole thing. The length of AC is 2/3 of the whole thing. And the length of BC is 2/3 of the whole thing. Now let's take some examples. In the figure, point C is the centroid of triangle PWE. So this C here is the centroid. This tells us that EH, PL, and WZ are median of the triangle. And we have point C as the centroid. Now, we are supposed to determine the length of EH. So this length right here, EH, and the length of CH. Now, we are given EC is 10. Now, we remember that the median of a triangle intersects at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. This means that we can write an equation. EC is 2/3 of the whole thing. So we can go ahead and write that equation up here. So that is EC is equal to 2/3 of the whole thing, which is EH. So that's the formula right there. And we're focusing on this median right here. So we plug values in. So looking at this problem here, we want to solve for EH. So but we're given EC. So then we can go ahead and say that our EC is 10 and that is equal to 2/3 of EH is missing. So we can just keep that as EH. So what are we going to do next is again solve for EH. This is the first one that we need to determine. That means how long is the distance from E going to the midpoint H. So we can get rid of the fraction here. We go ahead and multiply both sides by 3. We multiply the other side by 3 as well. Doing that, we can go ahead and cross the 3 out. We are left with 3 times 10 is 30. And that is equal to 2EH. Because then again, we already canceled out the 3. So that we can go ahead and divide both sides by 2 since we wanted to solve for EH. So that's the first one. So divide this by 2, divide this by 2 here so we can cross that out. So we are left with EH is equal to 15. So the length of EH is 15. So this whole thing from E going to H is 15. So that we can go ahead and put that answer up here. So that's 15. So we can solve for CH. Now looking at this problem right here. So we are given CH. Segment addition postulate tells us that this whole thing EH is actually the sum of EC and CH, so that we can go ahead and write that up here. So our EH is actually equal to the sum of EC, so EC plus CH. So if we add both of them, it's going to equal the total. Since we know that we have EH is 15, so we plug that in here. So this is 15 equals our EC is 10. So we got the 10 right there plus CH, and then the CH is the one that we're looking for, so that we can go ahead and solve for CH by subtracting 10 from both sides, minus 10 and minus 10, so that we can go ahead and cross the 10 out. We are left with CH is equal to 5. So the length of CH is 5. So we can put that up here. So CH is 5. That makes sense because since we have EH is 15, so from the vertex all the way to the midpoint is 15. So 10 plus 5 is 15. And the theorem tells us that the median of a triangle that intersected a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. And so 10 here is actually 2/3 of the whole thing, which is 15. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so let's go over the problem here. In the figure, point C is the centroid of triangle PWE. WZ is 18. Since point C is the centroid, it tells us that WZ, EH, and LP are the median of the triangle. So that we can go ahead and solve for WC and CZ. So if we look at the picture here, WC is this portion right here. And we are given that WZ, the whole thing, is 18. But we wanted only this part right here. Using the theorem that we started from the beginning, the median of a triangle intersects at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. This tells us that WC is 2/3 of the whole thing WZ. So we can go ahead and write that equation up here. So that is WC is equal to 2/3 of the whole thing, which is WZ. Now, we know that WZ was given to us and it was 18, so we plug that in here. So WC is 2/3 of our WZ. We put it in here. We got that up here. That is 18. So that we can go ahead and do the math here. WC is 2 times 18 is 36. And then that is divided by 3. And so we can go ahead and say that WC is actually 12. So this is the length of WC. So we can go ahead and label that up here. So this is 12. So I put that up here as well. So that's 12. Now we are supposed to solve for CZ. Now, looking at this, we know that the whole thing was 18 and we already got the WC. We wanted to solve for CZ. We are going to use the segment addition postulate, which tells us that the whole thing is actually sum of the two segments. So we can go ahead and write that up here. WZ, which is the whole thing, is actually equal to WC plus CZ. So that we can go ahead and plug values in. Our WZ is 18. And then our WC, the one that we solved, is 12 plus CZ. So that we go ahead and subtract 12 from both sides so that we can solve for CZ or ZC. It doesn't really matter. You can switch that. So that's minus 12 so that we are left with ZC is actually 6. 12 minus 18 minus 12 is 6. So this is the length of ZC. You can switch it around. CZ, it doesn't matter. So this is 6 right here. And this makes sense because if we add 12 plus 6 is equal to 18. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. In the figure, point C is the centroid of triangle PWE. LC is 4. Since point C is the centroid of this triangle, we can therefore say that WZ, EH, and PL are median of the triangle. So that we can go ahead and solve for CP and LP. So looking at this figure here, CP is located here. And then we have LP is the whole thing. And we are given LC is 4. So we can put 4 right there. We need to figure out what this is and what is that whole thing. We remember that the median of a triangle intersects at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So that we can go ahead and say that PC is 2/3 of the whole thing PL. So we can go ahead and write that up here, PC or CP, it doesn't matter. So CP is equal to 2/3 of the whole thing, which is PL. Now notice this very carefully. PL is actually the sum of PC and LC. So that we can go ahead and rewrite this to be CP is equal to 2/3. Again, PL, that's the whole thing. That's actually the sum of CP plus LC. So if we add the CP and LC, that's actually equal to PL. So that we can go ahead and plug the values in. We're given LC is 4. So we put the 4 in here. So that is CP is equal to 2/3. Then we have CP plus our LC again is 4. So we need to get rid of the fraction. So in order that we can do that, we multiply both sides by 3 so that we can get rid of this denominator 3. So I multiply this by 3. I multiply the left side by 3 as well. So we can cross this 2 out. So we are left with 3CP is equal to, so we can go ahead and rewrite this, that is 2. And then we have CP plus 4. We distribute the 2 to each of the terms inside the parentheses. This comes out. That's gonna be 3CP is equal to 2CP plus 8 because you have 2 times CP is 2CP. 2 times 4 is 8. Now we want to solve for CP. That's the one that we're looking for. So we can subtract 2CP from both sides by combining like terms. So minus 2CP. So then we are left with, here with just CP, because we have 3CP minus 2CP is just CP, and that is equal to 8. So this is the length of CP. So I'm just going to write that up here, 8. And so CP again is 8. Now we wanted to solve for LP. LP is the whole thing. Again, we are going to use the segment addition postulate that if we add CP plus LC is equal to the whole thing. So we can go ahead and rewrite this as LP is equal to CP plus LC. So then our CP, we plug the values in, is 8 plus our LC is 4. So that we have LP is 8 plus 4 is 12. So this is the length of LP. And that makes sense because if we add 4 plus 8 is 12. And if you notice, 8 is 2/3 of the whole thing, which is 12. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!